Great. This is the fifth place winners call. So, Andre, I'll turn it over to you for introductions.
Yes, so some quick introductions from our side. Hello, everyone. I'm Andre. I was one of the hosts for the challenge. I work in image features in Google Research. So maybe next we can have Bingi from our side.
Yeah, hello, this is Bing Yi. So also a co-organizer of this challenge. So also at Google Research working on image features.
And I think Kaifeng.
Hello, this is Kaifeng. Sorry, I'm in different time zone, so it's a little bit early on my side. I'm also working with the features team at Google, and we're developing features internal for internal use cases. Quite looking forward to your presentation today.
Yes, maybe we can have the winners introduce themselves now.
You may start your presentation.
Oh, can I start my presentation?
Yes.
Okay. Now start my presentation about the fifth place solution. First of all, I would like to thank you for organizing this competition. Thinking about the better embedding vector was very interesting. So today's plan to talk about this today. We are three-member team. All of us are college working in machine learning at NS Solutions company, and we are specialized in deep learning and image recognition. Our solution is basically to use OpenClip's bit edge as a backbone and train only the linear head with arc face. In addition, techniques such as weight decay, anti-alias, using image metadata, and the selection of the dataset improves the score a little. Using TTA also contributed to the improvement of the score. And these small improvements allows us to compete with other competitors. Here is a plot of the public and private scores from the beginning to the end of this competition. You can see that the two plots are very well correlated. And we can see that using our OpenClip bit L improved the score significantly in the early stage of the competition, and the use of ArcFace also improves the score significantly. The use of bit edge, which was released in the middle of the competition, boosted the score even more. In the following slides, we will describe the techniques of training the content of the used dataset and the test time augmentation, TTA. In this page, we describe how to train a linear head with ArcFace. We use the OpenClip bit edge as a backbone by calculating and storing the clip bit embedding vector in advance. The training can be accelerated. Input to the linear head is a vector of the clip embedding vector combined with metadata of the height, width, and aspect ratio of the original image. Linear head is a simple architecture consisting of the two layers, binomialization 1D and linear layer. The training parameter are shown here. Okay, so the final data set we used consisted of this. GLD-V2 has a very large number of digits, so it was sampled to be about 50 for each class. We tried many other data sets, but didn't use them because they didn't improve the scores. Our submitted model is processed like this. First, the process depends on whether the image is square or non-square. In the square case, TTA, test time augmentation, was performed using the resize image and the center cropped image. In the case of non-square image, classify the image first. For images classified as apparel, packaged goods, and toys, TTA is performed using three types of image: center crop, padding center crop, and padding hard center crop. For other images, center crop and padding center crop are used for TTA. In the case of square, the process looks like this. Resize, using resize and center cropped image. In the case of non-square, the process looks like this. Finally, I'll explain about anti-areas. This means that when resizing the image, setting the anti-areas option to true improve the score. The reason of this is that the anti-areas option is true when OpenClip is trained, so it is better to match it in inference. It is difficult to notice this because Touch Vision's resize function changes depends on whether the input is touch tensor or PIL object. Thank you. Question? Any other question? Any question? Question. So we are all not very good at sorting in English, so it might be smoother if you give us questions in text. Thank you. Okay, architecture. Is this right? Okay. How will upgraded patch no upgraded?
I think it's a different slide. If you go before a few slides.
The one. patchの
Yeah, this one.
家です。
This batch no average batch no. Simply batch no.
Yes, I sent another question about the impact of appending scalar features to the encoder output.
A little score boost, but this idea encoder is not no original image aspect. For example, Google landmark dataset very biased takes photo. For example, tower and very high take very biased aspect ratio, narrow wise and very high height image have biased.
Thanks.
So sorry.
Yes, I think Bingi sent another question.
Yeah, so I had a question regards you guys were performing another round of TTA just when the image belongs to apparel toys, and what is the other vertical. So I was trying to understand better here. It looks like you guys are using only the GLD data and the production 10K data for the training. So that process is at training only, or even at inference, when you recognize it's a image belongs to this 3 category, you will perform another round of TTA. So is there a reason for you guys to do so? And did you see some performance improvement for that strategy?
It is only for inference, but no use in training.
So does that mean, because it's a image retrieval task, so does that mean like when you guys get a query image, you will first decide whether it belongs to this 3 category, and then you process like the procedure to extract the features?
I really wanted to do 3 times TTA in all cases, but due to the inference time is over, so restricted to case for 2 times TTA.
I see. So does this approach actually brings, like, do you have an ablation study how much improvement this extra TTA brings in?
Okay. So wait. It improves about sorry. どこだabout 0.01 to from 1 to it's about 0.02 score in public
Sure.
by TTA. Yes.
Thank you. So I think based on like the evaluation experiments, you probably realize that there are like images belongs to these 3 category, and then using this 3 layers TTA is going to be beneficial in the like final metrics.
This benefit is very little.
Mhm.
Yes, it's about 0.00 to 1. So its benefit is very small. So
I see.
yes.
Thank you.
I posted a question about how do you train this classifier? Do you train it on some data created by yourself, or is like any public models, and then you group the classes by these categories?
Yes. It is very simple model, and there is no any other special technique. モデルセット使ったっけな。
We use public dataset, close で、なんだ、product 10K public dataset and other dataset combined and simply classifier training apparel or toy and なんだっけ3つ。まあ、apparel or toy and one class, we classify trained.
So basically, the classifier is trained also on the product 10K, sort of.
Sorry, in Japanese. 上の方でちょっとデータって書いてなかったでしたっけ？
いや、書いてないですね。
ああ。
Yes, I have another question about the arc face loss. Did you try a different loss or any other insights here on the loss? Is arc face the best one? Yep.
No good other loss. For example, elastic face and no effective. Arc face is best in case.
Thank you.
Yes. The classification in TTA. So trained. Yeah. Yes. Yes. We use TTA and 3 class or not classification use. Then so we trained.
Any other questions from our side? I think, or Bingy? I think I went through my list already.
So I asked the question I want to ask.
Yep, I think me too. If there are no more questions, maybe we can conclude. Yeah, I think also ask all the questions. Maggie, anything else you wanted to add?
No. Great.
Yep.
So I'll go ahead and
Congratulations
stop.
again.
Yeah.
I just want to say
Thank you.
congratulations one more time. Yeah.
Yes. From Kaggle as well. Congratulations.